Alrighty, you may use a calculator for problem number 1 only. Number 1, a radioactive element has a half-life of 2,760 years. What percentage of the original sample is left after 150 years? So I know that this is an exponential decay problem, so I am going to use, got it upside down, sorry about that guys. I'm going to use y equals CE to the KT. And then it didn't tell us how much of the sample I started with, so I'm actually going to start with 100. And then it tells me that the half-life is 2,760 years, so when the time is 2,760, I would be left with half of what I started with, so I'd be left with 50. So I'm going to be solving for K. So we're going to divide both sides by 100 actually. So I'll get 0.5 equals e to the 2,760k, and then I am going to take the natural log of both sides. So I'll have the natural log of 0.5 is equal to, remember on this one we can bring the 2,760k out front. The natural log of e is 1, and then if I solve this for k, k will equal ln of 0.5 over 2,760. So from here we've got y equals 100 e to the ln 0.5 over 2,760 t, and then it says what percentage of the original sample is left after 150 years. We can simply plug 150 in for the t, and when I do that I'll get 96.3%. Problem 2, find dy dx if y equals the natural log of the square root of x squared plus 1 all over x plus 1. Right before I take the derivative of this, I am going to separate this, so I'm going to make it y equals natural log square root x squared plus 3 minus the natural log of x plus 1. And then before I take the derivative, I'm actually going to go one more step. This square root is like a 1/2 power, which we're allowed to bring out front, so I'm going to rewrite this as y equals 1/2 natural log x plus 3 minus natural log x plus 1. And now the derivative of any ln problem is just going to be du over u. So in this case this would be my u, so I've got 1/2 times du in this case would be 1 over u, which would be x plus 3, and then minus, this would be u in this problem, so du would be 1 over x plus 1. Okay, and the way that I am going to, actually I wrote this wrong, I have x squared plus 3, so du actually on this one is 2x, sorry about that, and then my 2's cancel, so I am left with x over x squared plus 3, and then this said minus, and I didn't put minus, it should be minus 1 over x plus 1, and that is the derivative. Okay, problem 3, differentiate or take the derivative of f of x equals x squared ln x squared plus 7. This is x squared times ln, so we are going to use the product rule on this one. So f prime will equal 2x, and then g prime, since it's a natural log, we'll do du over u, so it will be 2x over x squared plus 7. So then taking the derivative, we'll do f prime times g, so we'll have 2x natural log x squared plus 7, and then plus f g prime. I'll get x squared times 2x over x squared plus 7. And I believe on this one, before I even simplify, I noticed that they both have a 2x, so I'm going to factor that out. So I'm going to factor out a 2x, and when I do that, I'll have natural log of x squared plus 7 plus x squared over x squared plus 7. And then I will be done. That's my derivative. All right, next one, evaluate the integral from 2 to 3 of x squared over x cubed minus 3. Right, I know in this problem, if I have a denominator with more than one thing in it, I would usually let that be u. So I'm going to let u equal x cubed minus 7. The derivative of x cubed minus 7 will be 3x squared dx. I notice that I have the x squared, I'm just missing the 3, so 3 goes on the inside, 1/3 goes on the outside. So if I go to rewrite this, I'm going to have 1/3, 3x squared dx turns into du, and then x cubed minus 7 is u. So if I have the integral of du over u, I know that that equals the natural log of the absolute value of u. My 1/3 tags along. And then I'll replace my u with x cubed minus 7. And then we're going to evaluate it at 3 and 2. So if I plug in 3, I'm going to get 1/3 natural log. 3 to the third is 27, minus 7 is 20, and then minus 1/3 natural log. If I plug 2 in, 2 cubed is 8, minus 7 is 1. And then the natural log of 1 is 0, so I'm simply left with 1/3 natural log of 20. Alrighty, and another way that I could write that, if you really wanted to be math fancy, it really could be the cube root of 20. Okay, problem 5, evaluate the integral of secant x over 3. Right, in this specific problem, if you have something next to the secant or trig that's not just x, you usually put it in parentheses, and then that gives you a good idea of what you would like your u to be. That would be x over 3. Another way you could write that would be 1/3 x. And then the derivative of 1/3 x would just be 1/3 dx. I don't have a 1/3 in there, and to compensate for it, I'll put a 3 out front. So now I have 3 integral of secant u du. Okay, and then the integral of secant u, hopefully you know this, would be 3 natural log absolute value secant u plus tangent u. And now I just need to replace my u, so 3 natural log secant x over 3 plus tangent x over 3, and then plus c, of course.